Welcome to True Projects. In this video, we are going to explain about a project titled Classification of Brain Volumetric Data to Determine the Alzheimer's Disease using Artificial Bee Colony Algorithm as Feature Selector. Alzheimer's disease is a progressive neurological disorder impairing the cognitive functions like memory and thinking. This motivation behind this research lies in the potential of data mining and the artificial intelligence techniques to streamline the Alzheimer detection, bypassing the time-consuming conventional approaches. Additionally, the study aims to guide the medical practitioners by identifying the brain region most pertinent to Alzheimer's, aiding the targeted intervention, emphasizing the early Alzheimer detection, vital role in mitigating its impact and enhancing the patient's daily lives. The research delves into establishment assessment methods like MMSE, neurobiological exams, and the medical history. Notably, the study introduced the innovation of employing the artificial bee colony algorithm to intelligently select the features for the Alzheimer classification, drawing from the volumetric and statistical brain MRI data. And the primary objective of this project is the utilization of artificial intelligence and the data mining technique to diagnose the Alzheimer's disease through the magnetic response imaging data analysis. An additional focus is placed on accurately distinguishing between the AD and the health control group within the MRI data, while identifying the specific brain region crucial for discerning the potential difference. In pursuit of these goals, we introduced the artificial bee colony algorithm as a feature selector for effectively categorizing the AD based on the volumetric statistical brain MRI data. Comparative analysis is conducted, pitting the BA-BC against the binary optimization algorithm like the particle swarm optimization, binary graph wolf optimization, binary differential evolution to ensure the comprehensive evolution. KNN, random forest, and support vector mission algorithms are employed as a classifiers during the feature selection process. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 on Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. Here we need to import the essential Python libraries and the modules like of data manipulation, visualization bar for C1 MATLAB and the machine learning sklearn and the web application development Flask. And the second step is exploring the dataset. The dataset containing the brain volumetric data is loaded and examined. This involves understanding the data structure, dimensions, and the variable types, along with the preliminary assessment of missing values and the potential outliers. And the next step is data processing. Raw data often requires pre-processing for effective analysis. It involves tasks such as normalization to ensure the consistent scales and handling the missing or the erroneous data points. And the next step is visualization using the Seaborn and the Matplotlib. Data visualization aids in understanding the data pattern and the relationship are employed to generate the informative visualization that can reveal the insight into the brain volumetric data and its characteristics. And the next step is of label processing. Label processing involves encoding or transforming the target variables into the suitable format for the machine learning algorithm. In this project, it indicates the Alzheimer's disease presence are prepared for the model training. And the next step is feature selection. It is crucial for the model efficiency and the interpretability. The artificial bee colony algorithm is introduced as a feature selector, helping identifying the most relevant brain volumetric feature for the Alzheimer's disease classification. And the next step is data splitting to the training and the testing. The data set is divided into the two subsets, training and the testing data. The train set is used to teach the model, while the testing set evaluates the performance on the unseen data. And the next step is building the model with different optimizations. And the first one is of combination of BDE, BPSO, BGWO, BABC. BDE is a stochastic optimization algorithm as binary differential evaluation for the feature selection. It involves generating the diverse candidate solution and iteratively refining them to identify the optimal subset of the brain volumetric feature that contribute to the significantly Alzheimer's disease classification. And the BPSO binary particle swarm optimization is a technique that simulates the behavior of the particle in the swarm, which utilizes a feature selector guiding the search for the most relevant brain volumetric feature linked to the Alzheimer's disease. And the BGWO binary gray wolf optimization ZIP, inspired by the hunting behavior of gray wolves, is incorporated to form the feature selection. By imitating the leadership hierarchy in the wolf pack, BGWO seeks the optimal subset of the brain volumetric feature, crucial for the Alzheimer's disease classification. And the next one is of BABC artificial bee colony algorithm as a feature selection in this project inspired by forecasting the behavior of honeybee colonies, iteratively identify the most informative brain volumetric features that distinguish the Alzheimer's disease cases. And the next one is random forest. It is a versatile ensemble learning method that constructs a multitude of decision tree during the training. And this project, random forest, is used for the classification model to predict the Alzheimer's disease based on the selected brain volumetric features. And the next one is KNN. It is a simple and effective classification algorithm that assigns the class label to an input sample based on the class label of its k nearest neighbor in the feature space. In this project, it is employed as a classification model to predict the Alzheimer's disease. It leverages the proximity of data points in the feature space to make the accurate prediction. And the next one is SVM. It stands for Support Vector Mission as a powerful classification algorithm that aims to find the hyperplane that best separates the different classes in the feature space. In this project, SVM is utilized as a classifier for Alzheimer's disease prediction. It seeks to identify the optimal hyperplane that maximizes the margin between of classes, thereby enhancing the classification accuracy. And the last one is of without feature voting classifier of SVC, RF, and GT. It is an ensemble technique that combines the prediction of individual classifier. In this case, support vector classifier, random forest, and decision tree classifiers are integrated, and it capitalizes on the diverse strengths of these classifiers to enhance the Alzheimer's disease prediction accuracy. And the next step is user gives the input. Here, a flash web-based interface allows the user to input the brain volumetric data for the Alzheimer's prediction. The input is processed and prepared for the prediction. And the next one is the given input is pre-processed for prediction. The input data is pre-processed and by using the trained steps of the previous one, and the next one is trained model is used for the prediction. The pre-processed input data is fed into the trained model, which will be used to regard the result of the Alzheimer's disease. And the final outcome is displayed through the front end. The final prediction outcome is displayed on the front end of the web application, providing the users with a conclusive assessment of Alzheimer's disease likelihood based on the volumetric data analysis. And the execution of the project. For the execution of the project, we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of the various folders like CSS, JavaScript, fonts, images within it. And the template folder containing of the HTML documents. It typically include of home, index, results, sign in, sign up pages within it. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is an SAV file which contains the algorithm information and is loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data, performing the specific operations. And the next one is notebook IPYNB file, which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code and the individual cell, making it a popular choice for the data science. And signup.db as a file appeared to be the database file that is used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we will need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues, and then click on the enter button. Here, after running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm opening this one and then pasting this link and then click on the enter button. Here we redirect it to this page containing of some information about it and the title of the project. Then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of the username and password. I'm entering those details. And then click on the login button. Here it will redirect it to this page containing of the details that are need to be filled. And I'm entering the details of visit, as of 1, and the MR delay is of 0, and the gender is of female, and the hand is of right, and the age is of 27, and the EDUC is of 87, and the SES is of 14, and the MMSE is of 2.0, and the CDR is of 27.0, and the ETIB is of 0.0, and the NWBB is of 1987, and the ISF is of 0.696. And then click on the predict button, and then by clicking this predict button, here I redirected to the result page and giving the result as of the patient is converted either dementia or non-dementia based on the OASIS MRA feature value. And by clicking on the home button, here we can re-enter the other details too. And I'm entering the details of the visit as of 2, and the MR delay is of 842, and the gender is of male, and the hand is of left, and the age is of 57, and the enter EDUC is of 82, and SES is of 16, and MMSE is of 1.0, and the CDR is of 28.0, and the ETIB is of 0.5, and the NWBB is of 1693, and the ASF is of 0.694. And then click on the predict button. Here it redirected to the result page, and it gives the result as of the patient is diagnosed as dementia based on the OASIS MRA feature value. And in conclusion, we have proposed a binary version of the artificial bee colony algorithm as a competitive method for classifying the Alzheimer's disease from the volumetric and statistical data of the brain magnetic resonance images. We compared the performance of BA-BC with the other binary optimization algorithms such as BPSO, BGWO, and VDE. The result of experiment showed that all the methods achieved it personal best by using the random forest as of the classifier.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.